Hi everyone, this is to give you a quick update. I mounted the circuit on a little project board, so it's all soldered now, and there's been a small change here on the diodes, and they're ultra fast diodes because of the frequency that I'm switching at is very high, and the 4007 diodes were actually overheating. These ones are staying cool. I'm getting though some heat buildup at the frequency that I'm pulsing my coil in these two ICs, which are the IR2103. So a lot of energy is being wasted in these here, but that's only because I'm at a very high frequency. There was an error also in the wiring configuration for the 4013, and I pointed that out to ground loop, and we're making the changes and revising that. So the main components though are working very well, and I'm very satisfied with the circuit at this time. So right now I have the circuit in operation. This 12-volt battery is feeding the power for the logic side here, and my isolated variac is feeding the capacitor bank here, which is charged at basically 50 volts. So we have 50 volt DC in this capacitor bank, which is what's going that's what's going to be pulsed by these MOSFETs here, back and forth, a flip-flop between positive and negative at the frequency that I selected on this LC tune coil. And there's my secondary, which is 3 turns, and I've got an ultra fast diode on that that's now picking up and filling a capacitor bank here. Now I've put a very large capacitor bank just for testing purposes, just to find out how quickly it can charge. And these are the largest capacitors I have, and each one of those are 6,000 microfarad, capable of 50 volts. There's the second one there. So we have a total of 12,000 microfarad capacitor bank right there, right? They're in parallel. And I have a very precise resistor that's attached to that. And that resistor there is a 10 ohm, and it's 1% accurate, capable of handling up to 50 watts. So what I'm doing is we have 50 volts going into the circuit. This is what the circuit is drawing without the coil connected. Right now the circuit is operating, okay? So it's pulling 26 milliamps on the AC. So let me show you here. My amp meter is taking from the output of the variac before it goes to the bridge rectifier. So we're using 60 hertz here, right? And it's coming through the amp meter here and going back to the bridge rectifier. So I know this amp meter is capable of measuring 60 hertz, no problem. So this is a very good way of figuring out what the circuit is drawing. So the circuit is idle right now. It's not charging the cap bank. This is our cap bank right now. It's got 0.28 volts in there. It's not being filled at all at this time. So to get the circuit going, all I do is I make the connection, okay, of these two wires here, and that gets the cap bank charged. And then we can see the difference, how much power is being drawn extra from getting the coil pulsing to charge that cap bank. Alright, so basically I've got it set at a point where there is no difference. It's not pulling any amp draws basically from what this circuit is taking just to operate at this time. So you'll see that once I make that connection, the cap bank charges, which is 12,000 microfarad, it charges very fast, and it's pretty well instantaneous. Within the first second it's charged, and all I'll do is I'll connect it and disconnect it, and you can see the difference in the meters right there. Alright, so here goes. So I'll position the camera so you can see all the meters. And connected. So it's charging that 12,000 microfarad cap bank, okay, to 3.15 volts. All right, and there's the amp draw. Keep your eye on that. 26. So it's fluctuating all the time. That's the power grid. But I'll disconnect it right now. All right, so we're back at 26. All right, so we were at 26. I'll reconnect it. Okay, still at 26. See, the cap is charged. Disconnect it again. We're still at 26. I'm charging that cap bank pretty well instantaneously. Connected to 3 volts with no amp draws. Disconnected. It's not changing. I know you don't believe me. It's hard to believe, but this is true. I don't post things that are not real. Connected. 3 volts. Again. Disconnected. Absolutely, it's not adding, it's not drawing more current. Connected. Disconnected. Connected. Disconnected. My meter here even has an ability to show you, a difference. There we go. Connected. Now it takes a little bit of juice when it first connects, but when I disconnect it, nothing. You don't see any difference. Connected. Disconnected. Alright, so if somebody can explain to me why I'm capable of charging a 12,000 microfarad cap bank with a continuous load of 10 ohms by connecting and disconnecting the coil, and I'm not getting any amp draw, can someone explain to me how this is possible? Because it shouldn't be. So I must be missing something. Now I can tune my my frequency to a point where I get an amp draw, and my voltage will be higher than 3 volts. I'll show you maybe here. I'll just put that wire on there. All right. So now if I tune my my frequency, you'll start seeing now the amp draws are higher, right? And the voltage though is being higher at the cap bank. And if I continue, so that's, see, now we're using 10 milliamps to get to that point. So I have it tuned to the point where it's not using. Right there, well, I think it's basically when I'm at about 3.10, somewhere around there. So about at that point. Actually, if I drop it to that point there, you see the minus there? I'll disconnect the coil. So it's actually sending energy back when it's tuned at that point. Connected. So at 3 volts, disconnected. So it goes backwards, basically, when I keep tuning it to drop, to get to that point. Anyways, interesting stuff. And this is all about resonance and trying to figure out what we can do with this. Thanks for watching.